All right. Our first unit in chemistry is a unit on measurement. And at the very beginning of measurement, we learn about a system that is used by scientists to normalize so that we can all talk in an equal manner. When scientists discuss and make observations and do different things, they use a system called the Sistema Internacional de Units. And basically what that means is it's SI units. It's a standardized system allowing us to have certain units for length, mass, time, temperature, amount of a substance, electrical current. It's a two-part system and it uses prefixes. So let me give you some examples here. So for length, okay, the unit is meter. Now, it's my first time using this little stylus thing, so bear with me. But meter. The abbreviation is a lowercase m. For mass, it is grams. Now, for a number of you, this is not new information. For time, the SI unit is seconds. Abbreviation, lowercase s. For temperature, this one's a little bit different. We use Kelvin. And that is a capital K. One of the things we need to remember on Kelvin, and I'm going to repeat this a number of times, it has no degree symbol. Amount of substance is the mole. And abbreviation is MOL. A lot of help on that one. Electrical current is amperes. And that is a capital A. Now there is one missing. All right, and I think we should add it. We'll add it in class. So, and it's volume. And volume is measured in liters. And it's a capital L. Now, why two parts? Well, that's because with the metric system, you get a prefix plus a base. So, for example, you've probably heard of kilograms. Kilo being the prefix, gram being the base, meaning that is a measure of mass. And this prefixes multiply and divide by base units of 10. All right, what you see here is you see a picture of the wall. On my wall in the classroom, it'll never be removed. There is a prefixes chart. It starts way up here at giga. All right, let's see if I can't grab onto the arrow thing. Let's see. I'm trying. Oh, I'm working on it. Yep, I got a pointer. All right, can you see that? There we go. So right there starts with giga. Then we go 1, 2, 3 steps down to mega. 1, 2, 3 to kilo. Then hecto, deca, base, deci, centi, milli. Notice 1, 2, third step, micro. 1, 2, 3, third step, nano. Now, whenever you're doing prefixes and different things involving SI units, I told you on the last slide, or previously, about multiplying and dividing by tens, right? So anytime you move in this direction, so meaning you go from, milli up to kilo, in that case, for every single time you do it, you divide by 10. Okay? Likewise, anytime you go in this direction, each step means multiply by 10. So let me give you an example here. 1 kilogram equals how many milligrams? Well, if we were to go and take a look at it, right? Kilo is here, hecto, deca, base, deci, centi, milli, right? So 1 times 10, so that's 10. 10 times 10, 100. 1,000. 10,000. 100,000. 1 million. So our answer would be, indeed, 1 million, right? If you like the Austin Powers movies. 1 million milligrams. And that makes sense because there should be a lot of itty bitty little milligrams in one big kilogram. A couple other things I want to make sure that I talk about real quick. You can look here and you could see, I know I'm getting that. You could see here that giga has a capital G, mega, capital M, kilo, lowercase k, H, capital D for deca. The base does not, so that is just grams, liters, etc. It does not have one, so that's why there's little stars next to it. It just says base. Deci is the lowercase d. Centi is the lowercase c. Lowercase m. That should be 2 L's, by the way. Micro is a weird one. It's this funky little, it kind of looks like a U. I'm going to draw it up here. So it looks like that, okay? And nano is just a lowercase n. All right, real quickly, a little phrase that I've taught myself to help me remember the order is King Henry died basically drinking chocolate milk. So, and notice the punctuation is correct as well. King, right? Kilo. Henry, hecto. Died, deca. Basically, meaning your base, no prefix. Deci, drinking. Centi, chocolate. And milli, milk. So if you remember King Henry died basically drinking chocolate milk, you would have king from kilo all the way to milli. All right, real quickly, in your packets, you're going to have Metric Conversions Review Worksheet. And I'm going to take you through a few of these just to talk it out before I set you free. Or actually, if you're reviewing this, I may have already set you free. A deciliter is blank, then a milliliter by a factor of what? So basically what you have to do is you got to look at the chart, right? King Henry died basically drinking chocolate milk. So a deciliter is further up the chart than milliliter. Therefore, it is larger. So go ahead, circle larger. Now, drinking stands for deciliter. Meter is stand for by milk, right? So drinking chocolate milk. So deci to centi is one step. Centi to milli is a second step. And I said every time you take a step, you multiply by 10. So therefore, this is bigger than it by 10 times 10, which is 100. Okay? Let's do this one down here. Deciliters into liters. So you're starting with 6.0 deciliters, right? And a deciliter is is drinking. Liter is a base, right? So to go from deci to base is going bigger by 10, okay? By one step. So multiplying by, or dividing by 10, because I told you whenever we go in an uphill direction, we divide by 10. So therefore, 6.0 divided by 10 is 0.60, and the label of liters.